The COVID-19 pandemic, as abominable as it might have been, remolded the course of humanity. Within 2 years of being locked up in our homes, reliance on technology surged. We were hooked to our phones, scrolling through social media, searching for any news about this disease which was wreaking havoc. Have you ever come across posts like the COVID-19 vaccine can generate magnetic properties in the human body, or lemon juice up the nose can kill the virus? These were some of the rumors that spread in social media. Hello everyone, I am Srijita Bhattacharji. I did an internship at Indian Research Academy, and during my tenure, I researched about how artificial intelligence can be used to classify COVID-19 tweets into real and fake. A study in SAGE's International Federation of Library Associations and Institutions journal by a researcher from the University of Alberta in Canada went over 9,657 pieces of misinformation in 138 countries. The study found that social media is the biggest producer of misinformation, accounting for 85% of it. Internet-based sources make up about 90% of COVID fake news. Among countries, India is the biggest source, 18%, followed by Brazil, 9%, and USA, 8.6%. The amount of misinformation is also the highest in India, at 16%, followed by USA, 9.7%, and Brazil, 8.6%. Thus, we see how much of a risk fake news has become in our society, which makes it quite important for us to differentiate between real and fake news. Now, let's have a look at what fake news essentially is. Fake news refers to false or misleading information, intentionally or accidentally presented as factual news, often with the aim of deceiving or manipulating readers or viewers. Fake news can be disseminated through various mediums, including social media platforms, websites, and online news outlets, rapidly reaching a wide audience and potentially causing harm by distorting public perception or influencing decision-making. The proliferation of fake news can undermine trust in reliable sources, contribute to social division, and have significant consequences, particularly in areas such as public health and politics. It is crucial to promote media literacy and critical thinking to combat the spread of fake news and maintain an informed society. An excess of information often triggers a situation called infodemic, which is the abbreviation of information epidemic. An infodemic refers to an excessive amount of information, both accurate and inaccurate, spreading rapidly during a crisis or significant event such as the pandemic. It can overwhelm individuals and make it challenging to discern accurate and reliable information from misinformation and rumors. The advent of digital platforms and social media has accelerated the spread of information during an infodemic. News, opinions, and rumors can circulate quickly, often reaching a large audience before their accuracy is verified, leading to confusion and potential harm. Infodemics highlight the importance of effective information management, including fact-checking, promoting reliable sources, and educating individuals on media literacy. Addressing an infodemic requires collective efforts from individuals, organizations, and technology platforms to mitigate the spread of misinformation and ensure access to accurate information. Fake news classification is crucial because it helps to protect the credibility of reliable sources and promotes trust in the information we consume. It allows us to identify and debunk false or misleading information, preventing its harmful effects on public opinion and decision-making. Accurate classification of fake news related to health like COVID-19 ensures people receive reliable information, preventing potential harm and promoting public safety. By helping individuals distinguish between reliable and false information, news classification enables them to make informed choices and decisions. Fake news classification supports the integrity of democratic processes by preventing the spread of misinformation that can influence election and public discourse. It encourages critical thinking and empowers individuals to become discerning consumers of news, fostering a more informed and media literate society. Classification helps reduce the polarization and division caused by fake news, fostering a more cohesive and united society. The dataset that I have used for tweet classification has been collected from GitHub user Malamodenius. This dataset was curated by scraping tweets from Twitter handles of health organizations using Twitter API and Social Scraper. It contains approximately 12,166 tweets. The dataset has three columns: ID, which is the serial number, tweet containing the article about COVID-19, and label, which can be either real or fake, indicating the authenticity of the tweet. The dataset is divided into three separate CSV files: train data, validation data, and test data. These files containing the training, validation, and testing data respectively. I have implemented three models for classification: the random forest algorithm, the gradient boosting algorithm, and the LSTM. Let's proceed with the random forest algorithm. Random forest is an ensemble learning algorithm that combines multiple decision trees to make predictions or classification. It uses a technique called bagging, where each decision tree is trained on a random subset of the data with replacement to create diverse models. The picture that is shown on the right is of a random forest. There are three decision trees of this forest, whose voting or the results have been collected and subjected to a majority voting, which finally decides the prediction or the result that is achieved by the random forest. To understand this algorithm, let's take a simple example. Imagine you have a group of friends working together to make a decision. Each friend is a decision tree, which is like a flowchart that helps make choices based on certain rules. Instead of just having one decision tree, a random forest has many decision trees. Each decision tree looks like a subset of the data. This is like giving each friend a different part of the information to work with. Once each decision tree has made its own prediction, the random forest takes a vote. It looks at all the predictions and chooses the most popular one. This voting process helps improve the accuracy of the final prediction. One advantage of using a random forest is that it helps control overfitting. Overfitting happens when a model learns too much from the training data and doesn't generalize well to new unseen data. By using subsamples of data and averaging the predictions, the random forest reduces the chances of overfitting. This algorithm also provides a feature importance measure, allowing us to identify the most influential variables in the prediction process. On applying this model to my dataset, I achieved an accuracy of 89.4%. Now let's proceed to the gradient boosting algorithm. Gradient boosting is a boosting technique that builds an ensemble of weak predictive models, typically decision trees, to create a strong predictive model. Imagine you have a friend who's really good at solving puzzles, but they have a weakness. They struggle with some parts of the puzzles, like the corners or the edges. So you decide to help them out. Now, here is how it works. You start by solving the entire puzzle yourself. Then you focus on the parts your friend struggles with the most, like the corners. You solve those areas really well and explain your strategies to your friend. Now your friend gains confidence and starts solving the puzzle alongside you. But they still struggle a bit, especially with the remaining challenging parts. So you step in again and help them with those specific areas, offering guidance and showing them the tricks you use to solve them. This process continues, with each round focused on areas your friends find difficult. Over time, your friend becomes better and better at solving the puzzle, and together you achieve a complete and accurate solution. Gradient boosting is similar to this puzzle-solving teamwork. Instead of puzzles, we have data and predictions. At the beginning, the algorithm starts with a simple model and makes predictions. It then looks at the differences between those predictions and the actual outcomes in the data. It pays more attention to the cases where the model made mistakes or struggles the most. As shown in the figure, The big black dots represent the input, which in our case are the tweets. The weak classifiers are represented by dotted lines, which are responsible for correctly separating the red and blue dots. These models are the weak learners. After each prediction, the algorithm creates a new model, but this time it focuses on those challenging cases, trying to correct the mistakes of the previous model. This model learns from errors and aims to make better predictions, specifically for those difficult instances. This process of creating new models and learning from the mistakes is repeated multiple times. Each new model that is added to the ensemble focuses on the remaining challenging parts and tries to improve the overall prediction accuracy. By combining all these models together with each one focusing on a different aspect of the data that the previous models struggled with, gradient boosting creates a powerful predictor that can make accurate predictions for a wide range of situations. It is a clever way to tackle complex problems and achieve better results. This model has achieved an accuracy of 84.96%. Well, we see that the accuracies of the previous models are quite impressive, but we can still improve it. This is where a deep learning model called LSTM has proven to be quite useful. LSTM, or long short-term memory, is a type of recurrent neural network that excels at capturing patterns and dependencies in sequential data, making it well suited for analyzing text data such as tweets. Now let us understand LSTM through a simple example. Imagine you're reading a story. You want to understand and remember the plot as you go along. Each sentence carries important information, but you also need to remember the context from earlier sentences to fully grasp the story. LSTM is like your memory assistant in this situation. It helps a computer or model remember and understand information in a sequence, just like you remember the storyline while reading the story. To understand how LSTM works, let's focus on the memory part. Imagine your memory assistant has different compartments to store relevant information. First, there is the input gate, which decides which new information is important to store in memory. It analyzes the current input and decides what to pay attention to. Then there is the forget gate, which determines what information should be forgotten from the previous memory. It looks at the previous content and decides what to discard or let go. Next, there is the memory cell, which stores important information that has been selected through the input gate and preserved by the forget gate. It maintains a long term of the sequential patterns. Finally, there is the output gate, which decides what information should be revealed as output based on the current input and the memory content. It stores the relevant context and generates the output accordingly. LSTM can handle variable length tweets by processing them one word or character at a time, capturing the sequential structure of the text. In the figure beside, I have shown the internal structure of an LSTM. This internal structure of the LSTM model makes it capable of learning to extract relevant features automatically from the input text, enabling it to capture linguistic and contextual cues that distinguish between real and fake tweets. It helps in contextual understanding. Due to its ability to remember and consider past information, LSTM can understand the context of a tweet, including sarcasm, irony, or linguistic nuances that may indicate fake information. LSTM models can also capture temporal dependencies within the text, such as the order of words or phrases, to identify patterns that differentiate genuine tweets from fake ones. LSTM's ability to capture complex patterns and contextual information often leads to higher accuracy in classifying fake tweets, enabling more effective detection of misinformation. Our LSTM model has achieved an accuracy of 93.26%. So that concludes our project pretty much. Finding a suitable dataset for the project was quite cumbersome, but after much research, fortunately I came across this dataset, which is very well organized with no missing tweets or labels. On researching about the infodemic, I came to know how impactful this situation has really been. It is true that fake news has always been present online, but the amount of fake news increased exponentially during the pandemic. Since 2020, numerous papers have been published where researchers have applied innovative techniques on more complicated and expansive datasets. It is worth giving a thought that if these relatively simple models are so efficient in classifying real and fake news, how well can more advanced models do the same task? At this stage, researchers have been able to design models with a 99% accuracy, which is quite impressive to be honest. Now, it is already quite difficult for humans to identify or differentiate the fake news from the facts, even if one has much knowledge about the subject. Even though deep learning models have shown significant progress in understanding nuances in text, the Google chat box being a prime example, we still have to go a long way to design an omnipotent model capable of comprehending human emotions. Considering we are just at the beginning of the AI revolution, there would be much better models in the future, capable of performing even more complicated tasks. I have uploaded the code of my models in GitHub, and here is the link of the blog post. You will get the link to the code at the end of the blog. Thank you everyone for your time and consideration. I express my immense gratitude to Indian Research Academy for providing me the opportunity to explore and learn.